I'm going to introduce you to a new number. Find that number on your calculator. See what it's equal to. And then we're going to graph this function. Where's your calculator? Find the number e. $2.7. And it keeps going, and it looks like it has a pattern of the 1828, 1828, but it doesn't. It goes different after that. And it's another special number like pi. It's the number e, and it comes up a fair bit in calculus. And it's related to exponentials, and it's related to logarithms, and we're going to be doing a lot of work with the base of e as well. So we need to be able to graph it and graph examples with it as well. The graph, because it's a number of 2.7, will look like this, just like every other exponential graph. It will have an asymptote here at y equals 0, just like every other exponential graph. It'll have the point 0, 1, because if you plug in 0, anything to the power 0 is 1. And if you plug in 1, you get e. And that's your parent graph. So I want you to try to graph y equals 3 e to the x minus 2 plus 1. So here we have the first thing, the e's are part of the parent graph, so that's not going to affect the transformations. The 3 is a vertical stretch. The 2 is going to go 2 to the right, and the 1 is going to go 1 up. So when we look at our 2 points that we know, which are 0, 1, and 1e, we do all of our stretches and all of our reflections first. There's only one, which is y by 3. That'll get you to 0, 3, and 1, 3e. I'll put the asymptote on here already as well. Then we do all of our translations. We do have 2. We're going to go 2 to the right and 1 up. 2 to the 4, 2, 4, and 3, and you'll write it as 3e plus 1. Again, the asymptote's only going to change if you move it up and down, and we do have a translation 1 up, so your asymptote's going to become y equals 1. So when you go to graph this one, we're going to have an asymptote here at y equals 1. We've got the point 2, 4. And we have the point 3, 3e plus 1, and that's going to be close to 9, between 9 and 10. So we'll just label it as 3, 3e plus 1. And we have the same shape that we had before. And there's your graph.